So welcome students, welcome once again. So from today we are going to start with questions of definite integration. I think we have completed so many questions on indefinite. So here again I will try to cover each and every important aspect, the type of question, and of course the most important of at least one or two questions based on the most important property which I call the Bahubali property. Okay, let's start. See, the first question which I chose for you people for today is a bit different question here, bachcho. So why am I saying it a bit different question? See, because see, whenever you are given such an integration, so you are given that integral from 0 to 1 sine t over 1 plus t is equal to a, you be sure that normally we won't be able to solve this integral. So that's why they have given, okay, that's why they have given that, okay, there's a value, let us assume the value of this integral to be a, then you have to evaluate this value, the value of this integral, and we all know that we can find the value of this integral only when we can convert it to that form. So that's the only idea behind sharing this question. So the whole focus, the entire focus should be on converting this integrand to this form sin t upon 1 plus t form, and moreover, see, you can compare two definite integral. I mean, you can add them, you can subtract them, or you can compare them as equal or non-equal only when you have same like bounds also, the limits also, lower limit and upper limit. So we need those limits to be 0 and 1. So now let's start. See, to start with, I will see, the first thing I will do is, since we need sin t here, it's x by 2. So the first thought process to start with is, okay, why not to replace x by 2 by t? So let's do it. So in that case, of course, we need to replace dx also, and that will be 2 dt, and the limits also. So here when x is 4, so let me write, when x is 4 pi minus 2, implied t will be half, so 2 pi minus 1. When x is 4 pi, so that means t will be half, 2 pi. So therefore our integral will be, so integral is, so instead of dx, what are we going to write? We are going to write 2 dt here, and wherever we have x, we'll be replacing it with 2x bachos. Okay, so let's do it. So it is like integral, limit goes from 2 pi minus 1, so limit goes from 2 pi minus 1 to 2 pi. This will be sine of x by 2, which is t, sin t, dx is 2 as a constant, dt upon, in denominator we have 4 pi plus 2 minus x, and x is 2t, so minus 2t. Okay, just let me check it, 4 pi plus 2 minus 2t bacho, right? Now that's it. So that's the first system. Now again the important, one more thing, we can take 2 common from denominator. So let's simplify as much as we can. So sin t, so take 2 from common from denominator, you get it as 2 pi plus 1 minus t with respect to t, 2 and 2 is also gone here. So therefore our integral is now 2 pi minus 1, integration goes from 2 pi minus 1 to 2 pi, it's sin t over 2 pi plus 1 minus t dt. Now again, the target is to get 1 plus t in the denominator. It can be 1 plus z, it can be 1 plus y, it can be 1 plus x, but 1 plus variable in denominator, and the limit goes from 0 to 1. So now when I started thinking on it, see, you may have different idea, everyone can think differently, okay, and of course I believe and I will accept that you may have some better idea also, but how I started doing it, then I applied, that's what I said in the beginning of this video, Bahubali property. So what's that property? So if I write this, that's the most important property I consider in our definite integral. And if you people remember, those who have been following these videos regularly, I've used this property in series questions also, I think in binomial question related to series of binomial coefficient. What is this property? This property says integral from a to b f of x dx will be same as integral from a to b f of a plus b minus x dx. Okay, so applying this property, I believe that everyone of you must be remembering this property. It's a very common and very useful property here. So applying this property in the integral, so So I'll be replacing t by sum of upper limit and lower limit. So it's 4 pi minus 1 minus t. So you have to replace within function the variable of the integral x by a plus b minus x. So t by 4 pi minus 1 minus t. Okay, that's why. In denominator, what we had? In denominator, we had 2 pi plus 1. So it's 2 pi plus 1 minus. Instead of t, I'll be writing 4 pi minus 1 minus t. Okay, dt. So let's see what do we get here finally. So therefore, I is now 4 pi. So let's do it patiently. Okay, sine 4 pi. So if I write sine 4 pi minus theta. So with which identity are we going to compare it? So we'll be comparing it with sine 2 pi minus theta, and since it's in fourth quadrant sign is negative, so it's minus sine theta. Okay, so I will be writing it as 4 pi minus 1 plus t upon, now simplify, 2 pi minus 4 pi is minus 2 pi. Plus 1 is plus 2 and plus t. That's what we get in denominator. Now, sine 4 pi minus theta, as I said, is minus sine theta. So, I'll be writing this integral in numerator as, so I is minus is out of it 2 pi minus 1 to 2 pi sine of 1 plus t upon, that's what we get, isn't that? And in denominator, it's minus 2 pi. So t plus 2 minus 2 pi, and that's our dt, right? Now see, again, if I replace here, look at here, if I replace t by 2 pi minus 1, so you get 1 here. If I replace t by 2 pi minus 1, we get 1 here. So now the next idea is, since we need 0 here, okay, so I will assume t plus 1 minus 2 pi as new variable z. Let's try. Assume, replace t plus 1 minus 2 pi by z. See, why am I doing it now again? See, there were two targets. To get the integrand in the form of sin z upon 1 plus z type of thing, and moreover, to get the limits also as 0 to 1. Okay, so you can say that we missed that thing. We already had sin t here, and now we have sin 1 plus t here, but now my focus is to get the limits from 0 to 1. So now you put replace t by 2 pi minus 1. So as t is 2 pi minus 1, imply z is 0, and as t is 2 pi, z is 1. So once, I think, that's my belief, once I could match the limit, I believe we are very close to it. So 0 to 1, and now dt is of course dz. Okay, now we will be replacing t plus 1 by sine 2 pi plus z, and we got this one also. See, that's what I say. If we match the limit, mostly we are very close to the form which we need. That's what I believe, that's what I said. Now this is nothing but 1 plus z, and we got it. But I am missing something. There was negative sign here, right? So therefore, our integral is now sine 2 pi plus theta is sine theta. So minus 0 to 1 sine z over 1 plus z dz, and this integral is nothing but, see, just by changing the variable. So 0 to 1 sine x upon 1 plus x dx, 0 to 1 sine t upon 1 plus t dt, 0 to 1 sine z upon 1 plus z dz, they all have the same value. So this is nothing but minus a, and that should be the answer here. So that was the first question. To start with, our questions on definite integration, I believe you would have at least learned the process, the steps, or the goal which we fixed to evaluate this integral. So the target was to convert these limits to 0 to 1, and of course the integrand to this form, so that I can compare this integral with this integral and get the answer in terms of a here, bachcho.